So we need to write an equation of a circle that's tangent to this. What's this? A linear equation, a line, right? Yeah. So we got to find a circle that's tangent to this line but has its center at 5, 1. Okay? To help you with the visual aid, I'm going to draw a rough sketch of this situation here. One, 2, 3, 4, 5, 1. So there's the center of the circle. My line is x plus 3y equals -2. If I want to graph that, I can do one of two things. I can find the x and y intercepts by plugging in zeros, or I can change it to slope-intercept form, y equals mx plus b, whatever you guys prefer. I like the intercepts. I think it's a little faster. If I plug in a 0 for y, x is equal to -2. So I know my x-intercept is right here. To find my y-intercept, I plug in a 0 for x. 3y equals -2. Y would equal -2/3. So about right there is my y-intercept. And then if I would get out a straight edge and draw a nice line, it would end up looking something. Again, I'm just kind of rough sketching this thing here. So it would look something like this. So my circle has to have this as its tangent line. Okay? So how's that possible? So if this is my center, is that okay?
No.
Why not? Not touching it just once. That's not a tangent line. It's a, anybody remember? Chord. This part of it is a chord, but when it's a line, it's called a secant line. Okay, but yes, just the segment inside, nice, is a chord. Okay, a secant line hits it more than once. A tangent line just grazes it at one location. So what do I need to do to that circle?
Make it graze it at one location.
Okay, so I might need to shrink it just a little bit from what I had. So it needs to be something like this, give or take. I know that's not quite in the center. I can do better. I can do better. I can do better.
Oh, that was bad. Oh, that was really bad.
That was so
Dang
much
it.
worse.
You thought that was better?
It's not.
That's a lot harder than
Is it?
Definitely
Perfect.
went
That
over
looks
the
really
line.
good. A professional artist to be here all
Definitely
week.
went over the line.
Okay? Alright, so I need a circle that has this for a tangent line. Well, the tough part here is obviously figuring out what? The radius. Okay? Here's how you would go about doing that. If I have a circle whose tangent to this line, there's one thing that is true. This radius right there, which touches at the point of tangency, okay, that radius, it is perpendicular to the tangent line. It makes a 90-degree angle with the tangent line at that point of tangency, at that point where they touch. Alright? Now, the reason that is significant, okay, is because I know the slope of this line. A lot of you guys put this into y equals mx plus b form, and you got a slope of -1/3. If this line has a slope of -1/3, then this line right here, that's perpendicular to it, would have a slope of what?
1/3.
3/1. Positive 3/1, because it's opposite reciprocal, remember? Okay? So this line right here has a slope of 3. What was the slope of this line? No, this one, the blue one.
-1/3.
-1/3, right? The slope of that blue line was negative 1/3. So therefore the slope of this line, which we know is perpendicular to it, remember how perpendicular lines have opposite reciprocal slopes? So what's the opposite reciprocal of negative 1/3?
3.
Positive 3. So I know the slope of this line has to be 3. Okay? Now, it looks to me like it hits right here at this exact coordinate, but we don't, remember this is a rough sketch. Okay, this is a rough sketch. I didn't do anything really exact here. Okay, so I need to figure out what this coordinate is. Because then, once I figure out this coordinate, can't I use Pythagorean's theorem to figure out my radius? So what I'm going to do then is I'm going to find the equation of this line. Okay, well I know the slope is 3, and I know it has to hit the center, right? So it passes through this point, has a slope of 3. How about y minus 1 equals 3 parentheses x minus 5, point slope form?
What?
Okay, how about y equals 3x plus b, plug this in for x, plug that in for 1 and solve for b?
Yes. Okay.
You guys in your slope intercept form.
Yep, that's what we were talking about.
Takes too long. Okay? That's perfectly fine. Solve it for b, then write your equation. Okay? Y equals 3x minus 15, add the 1 minus 14. Okay?
What did we just find?
This line.
Okay, thank you.
Yep. Now again, why am I finding the equation of this line? Well, I want to know where this line and this line meet, because if I can find that coordinate, then I can find my radius. Okay? How do I figure out where those two lines meet? Graph it, or table values, or set them equal to each other.
Oh,
A lot of you put this into slope-intercept form, right?
yeah.
That's actually probably beneficial right now. When you put it into slope-intercept form, you got y equals negative 1/3 x minus 2/3.
Yeah.
So now why can't we just set this equal to this to see where they meet? Because aren't we wanting to find out where this line, which is this right here, we want to see where that line meets this line, right? Because once we find this coordinate where those two lines meet, then I can figure out my radius. So to figure out where those two lines meet, just set them equal to each other. When does this equal this? So when does negative 1/3 x minus 2/3 equal 3x minus 14? That, you can solve that equation, right?
Yeah.
Okay, what do?
Oh. This wasn't very fun to do.
Come on, somebody.
Oh.
This is algebra 1 here.
Yeah,
Let's
I'm
go.
doing it.
Add 1 over 3x to the other side.
Add 1/3 x to both sides. That sounds great. So now I have 3 and 1/3 x over here. Okay. I'm going to change 3 and 1/3 to 10/3. Okay. You can make it 3.3 repeating. That's fine.
Add 14.
Add 14 to both sides. Okay. So I'm adding 14 to negative 2/3. Your calculator is going to give you 13.3 repeating. Okay. Which is 40/3. And then you divide each side, or excuse me, I'd multiply both sides by 3/10, and you get x equals 4.
Oh, that would have been smart.
Okay? So now that you know the x coordinate is 4, how do you figure out the y coordinate? Plug 4 in for x somewhere. 3 times 4 is 12. 12 minus 14 would be negative 2. So this coordinate right down here, well, my sketch was pretty doggone close.
Mine wasn't.
Okay? So this coordinate right here is 4, -2. Now that I know this coordinate, and I know the center's at 5, 1, let's use the distance formula, Pythagorean's theorem, whatever you want to do to figure out what the radius is. Okay? Or because this picture is so good, I'm lucky enough I could go, well, there's my right triangle, I rise 3, I run 1, 3 squared plus 1 squared would be 10, right? So this has to be the square root of 10.
Yeah.
Right? Pythagoreans? 3 squared plus 1 squared is 10, square root that. So my radius equals the square root of 10, and now you can write your equation. My answer would be x minus 1 squared plus y minus 5 squared equals what? Square root of 10 squared, which is 10.
Just as a reminder, how do we find the radius with the Pythagorean theorem? Instead of using sketch?
So, if you want to plot this point, plot that point, make your, you would still use your sketch, or you're just thinking, okay, how far do I run? 1.
Yep.
How far do I rise? 3.
Got it.
1 squared plus 3 squared
Okay.
equals radius squared.
Got it.
Yes, sir.
Wouldn't it be x minus 5 and y minus 1?
Oh, wow, yes.
That's what I was writing
Yes.
down, but then.
Sorry. X minus 5. Thank you, thank you.
What?
X minus 5 squared plus y minus 1 squared equals your square root of 10 squared. Yep. My mistake. Alright, what questions do you have on this? So your thought process here is, okay, I got my center, I need to find my radius. Okay? Well, the first thing you want to do is find the equation of the line that would go through the center but be perpendicular to this. So you got to find the equation of that line first. You want to find that equation because then once you find that equation you can figure out where that line meets this line, and that'll give you a point on the circle, because what good is a point on the circle then for you? It helps you figure out how far the center is from that point on the circle, which will give you your radius. There's a lot of thought process going on there, and I really like the problem because it covers a lot of algebra and skills, algebra 1, linear equations, lines, intersection points. So you can expect to see one like that on either the first or second assessment.